Hello again. In this video, we're going to be solving quadratic equations. So quick review, last time we solved by factoring, and the steps to solving by factoring, you had to get it equal to 0. You had to then factor one side. And when you did that, you ended up with two things being multiplied together that gave you 0. So then you used your zero product property to set each part equal to 0. Whatever the inside was the parentheses, you set it equal to 0. I don't know what to say. All right, and that gave you two parts that you could actually solve because they were linear parts. So you could then solve them and get your answers. The problem is you're not always going to be able to factor your quadratic expressions. So for that, we have to use a different method. Before we go to that method, let's look at what it looks like when we graph a quadratic equation. So here we have a quadratic equation or quadratic function in standard form. Standard form means you have the x squared in front of the x term in front of the number. Okay, so it goes from degree from biggest to lowest. Now these letters are actually important. This A and B and C, remember where they're at in standard form because we're going to use those in a minute when we're solving. Now the graph is something that looks like this, and this is called a parabola. So a parabola is the graph of a quadratic equation. Now, the parabola can look like this, or if the a value is negative, it will be upside down. Now, the special part of the parabola that you're going to be asked to find many, many times are these points right here. These points are what we call zeros. Okay, because the y value at those points are 0. So if you're asked to find those, you plug in 0 for y. Other names for that, they may ask you to find the roots. They may ask you to find the solutions. Or they may ask you to find the x-intercept, which you should be familiar with from linear graph. All right, so the method that we're going to use to solve these quadratic functions, the method that always works, is called using the quadratic formula. All right, so in order to use the quadratic formula, you still have to follow some steps, though. We're going to get the equation equal to 0 and in standard form. So first, you have to get it to where it looks like 0 equals some number times x squared plus some number times x plus some number. And sometimes some of these will be missing. In that case, the number is 0. So then you got to figure out what a, b, and c are. Okay, after you figure out that, you plug it into this formula. And I know this formula looks complex, but I'm gonna show you or teach you an easy way to remember it. We're using a mnemonic device, which is we sing it to the tune of Pop Goes the Weasel. I'll do that for you in just a second. After you plug it into the formula, you evaluate what's called the discriminant. Now the discriminant is the part that's underneath the radical. It's b squared minus 4ac. And it's called the discriminant because it discriminates between the ones that have two answers, two real number answers, one real number answer, or zero number answers. And I know the word discriminate is has a negative connotation to it because what it means to separate things based on a trait, and that's basically what this is doing. It's separating our quadratic equations into three different parts. Now, after you evaluate the discriminant, so you do this part and you put it back in there, you're going to finish solving. Now, if your discriminant is negative, you're going to get a non-real answer, and we're not covering that in Math 2. So if you get a negative in here for your discriminant, just put no real solution. After that, you finish solving, so you take the square root of your discriminant, you add the negative b, and then divide everything by 2a. At the very end, make sure you check your answers, because with these quadratic formulas, sometimes you'll have what's called extraneous solutions. So those are called extraneous solutions. What that means is that you had a extra solution that you get from the formula that doesn't actually work when you plug it back into your equation, your original equation. All right, so let's do some examples now. For the first example, we've got x squared equals negative 3x plus 40. So our first step is to get it equal to 0 and in standard form. All right, in order to do that, you can do two things. You can either subtract x squared from both sides, or you can add 3x and subtract 40 from both sides. Okay, I'm going to take the easy way this time. Well, I'm going to get it. I like having my leading coefficient be positive, so I am going to add 3x and subtract 40. You'll get the exact same answer in the end, no matter what you do. So feel free to try it the other way. All right, so I get x squared plus 3x minus 40 is equal to 0. These things cancel out and leave me with 0. So that's the first step. Second step, I've got to figure out what a, b, and c are. So in this case, my a value is 1, because there's no number in front of the x squared, which means the coefficient is 1. The b value is 3, and the c value is negative 40. So now that I figured out what a, b, and c are, I'm going to use my quadratic formula. Remember, it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'll sing it every time that I write it. I've got to where I can almost not write it without singing it. So that's the tune of Pop Goes the Weasel. It's how you remember that. It's a nice, easy way to remember it. It gets stuck in your head, though, be warned. And so here we go. I want to now plug in a, b, and c into the formula. All right, so negative b is negative 3. Now, some people say the opposite of b, because if this was a negative 3, this would be positive 3 right here. So just know you take the opposite sign there. So negative 3 plus or minus. Now, this symbol right here means that we have two different answers. One time we're going to add, the next time we're going to subtract. All right, so negative 3 plus or minus the square root of b, which is 3, squared minus 4 times a, which is 1, times c, which is negative 40, all over 2 times a, which in this case is 1. All right, so now I'm going to evaluate my discriminant. My discriminant is the 3 squared minus 4 times 1 times negative 40. 3 squared is 9. Negative 4 times 1 is negative 4 times negative 40 is negative 160. Well, negative 4 times negative 40 is positive 160. So I get 169 for my discriminant. This is positive, so that means I am going to have two real solutions. Now I'm going to take that and I'm going to plug it back in and finish evaluating. So we got negative 3 plus or minus the square root of 169 all over 2 times 1. All right, so simplifying this now, I can figure out what's the square root of 169. And you can refer back to the lessons on simplifying radicals if you need to. That's the reason why we did it, so we could simplify these things. 169 is 13 squared. So that's going to be x is equal to negative 3 plus or minus 13 all over 2. Because the square root of 169 is 13. Now, to figure out what my final answer is, I've got to take and do negative 3 plus 13 divided by 2. And negative 3 minus 13 divided by 2. So we've got negative 3 plus 13 divided by 2. And negative 3 minus 13 divided by 2. Negative 3 plus 13 is 10, divided by 2 is 5. So we get x equals 5. Negative 3 minus 13 is negative 16, divided by 2 is negative 8. Now my final step is to check. So I'm going to take these values and plug them back in up here. So I'm going to start with the 5. So I've got 5 squared equals negative 3 times 5 plus 40. 5 squared is 25. Negative 3 times 5 is negative 15. Negative 15 plus 40 is 25. So that one works. Let's try negative 8 now. So we've got negative 8 squared equals negative 3 times negative 8 plus 40. Negative 8 squared is 64. Negative 3 times negative 8 is positive 24. 24 plus 40 is 64. So that one works. So in this case, both of our answers that we got work. They're both solutions. Now I know it seems like a lot since I was talking all the way through it and I had to stop and sing and all that, but it's really easy to get the right answers as long as you follow the steps. And also remember that this is not the only way that you can solve some quadratic equations. And this one you could definitely factor and solve by factoring. And if you want to check this answer by doing that, feel free to go ahead. I'm going to go on to another example where you have to use the quadratic formula because it's not factorable. So here we go, example 2. We've got 9x squared minus 11 equals 6x. I'm going to start by subtracting 6x from both sides. So we get 9x squared minus 6x minus 11 is equal to 0. Now I got to figure out what A, B, and C are. So A is 9, B is negative 6, and C is negative 11. Now I'll plug those things into my formula, which goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm going to plug in negative 6 for b. Now since this is negative, this is going to be the opposite of that, which is positive. So we got x is equal to positive 6 plus or minus the square root of negative 6 squared minus 4 times 9 times negative 11 all over 2 times 9. The next step is to evaluate my discriminant. So we've got negative 6 squared minus 4 times 9 times negative 11. Negative 6 squared is 36. Negative 4 times 9 is negative 36. And we're going to multiply that by negative 11. Okay, I'm going to multiply that over here. We got 36 times 11. 1 times 6 is 6. 1 times 3 is 3. 0, 6, 3, 396. All right, so this is going to be 36 minus, plus, because it's a negative times a negative, 396. Okay, so when we add those, 6 plus 6 is 12. Okay, so it's going to be 3. It's 432. So I'm going to plug that. Now that's positive, so we have two positive, or not positive, two real solutions. I'm going to plug that back into my discriminant and finish solving. So we get x is equal to 6 plus or minus the square root of 432 all over 2 times 9, which is 18. Now, 432 is not a perfect square. So I've got to simplify it. So I'm going to make my factor tree. 432 is divisible by 2. 2 goes into 4 2 times. 2 goes into 3 once. So then I have 12 left over. And 2 goes into that 6 times. All right, so then that's factorable by 2 again. That's 108, which is 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. I got kind of small there at the end. But anyway, so we're looking for pairs. There's a pair of 3s. There's a pair of 2s. There's a pair of 2s. All right, so we get x is equal to 6 plus or minus 2 times 2 times 3. That's 4 times 3, which is 12. Square roots of 3, so it's left over there, divided by 18. So when we split this up, we get two different things. We have to simplify the fractions anytime we can. Anytime these three numbers have a GCF, we have to simplify it. So it looks like this. We've got x equals 6. I'm going to leave the plus or minus there. So let's just go ahead and simplify. The number 6 goes into all three of these. So I'm going to just divide all of them by 6. So we get 1 plus or minus 2 square root of 3 divided by 3. And since we can't simplify 1 plus 2 square roots of 3 over 3, or 1 minus 2 square roots of 3 over 3, I'm just going to leave it like this, because you know whenever you see the sign, you got to do both. So there's actually two answers here. Now, for the sake of time in this video, I'm not going to check this answer. You can do that on your own, or I'll show you how to do it with a calculator in class. But for now, also know that if you don't see any, if it looks just like this and there's no parentheses or anything, usually you don't have any extraneous solutions. But we're going to check that tomorrow in class to make sure. All right, so hope you have a good one.